Hello guys, welcome in Unified IT Solution. Today we are going to discuss about the Splunk architecture. So let's start. So the main key component of Splunk architecture is universal forwarder, which is used to collect the data from various source and send it to the indexer. If you have the heavy forwarder, so it will send first to the heavy forwarder and then it will send to the indexer. So the next component is heavy folder, which can be filter your data, index and forward it to the indexer. Indexer is where it stored your data and index the data and make it searchable. Search ad provide the user interface for searching and reporting your data. The deployment server distribute configuration update to forward and other Splunk component. Cluster master manage indexer cluster. License master who manage the Splunk license across the environment. Data model and knowledge object. So transfer and structure raw data for more meaningful insight data flow in Splunk. So we'll see today these all component details and how the Splunk works. So before that, I just wanted to go through about the data flow in Splunk. So first step is data collection, forward the data, then index the data, then search and reporting data and create knowledge object like alert monitoring, and Splunk can generate alert report dashboard based on your search result. Now I'm going to show how this Splunk flow work, how the each component works. So for that I had draw a simple graphic in paint and I will going to explain. So guys, let's see the Splunk architecture. So I'll explain here. So you see here this box. So these three box, four box, one, two, three, four. So these books are nothing but these are the client server where application logs are reside. So what we install on this forward, we install all this like 1, 2, 3 and 4 will install. Each of them will install the UF. So I just mark this as a UF server, universal forwarder. So we'll install the UF on this 4 server and then this universal forwarder will send the data to the this send the data to the heavy forwarder. On which port it will send the data? It will send the data on port number 997 to the HF. So these three server are our HF1, HF2 and HF3. Let's mark it HF1, HF2 and HF3. HF3. So we have three heavy forwarder. Now universal forward will send the data from the client server. So these all are the client servers. So I'll mark in them as client servers. So we have four client server which send the data on HF1, 2 and 3, and this is our deployment server. So all this connectivity like this is a DS. So universal forwarder will connect to the HF on which port number it will connect on the 8089, and HF will also connect on the 8089. In our first video we already explained like what is the use of deployer and deployment server and what is the use of HF. So but I'll give little overview. So UF will collect the data, it will send to the HF, and DS is to manage the deployment configuration over the HF. Let's suppose we have more than one, like we have thousand or hundred of universal forwarders. So how to manage the centralized configuration through DS? Similarly to that, any configuration we wanted to distribute over our three HFs instead of individual login, we could manage that configuration through DS. We can create on single place and we can push over the HF. The configuration we already discussed, but I will make a separate video how DS will work. So then this one. So what HF can do parse, filter and mask your data. So it will, we can control what to send to the indexer. So from here it will send the data to indexer. So on which port this send the data again. So there's a there's a catch, guys. So this will receive the data, and again this will send the data on which port. It will again send the data on 997 port. So 997 port. So we'll have to enable the receiving as well as forwarding on HF. Either it will only receiving, then it won't be able to forward the data to the indexer. So receiving and forwarding both will be enabled on the HF. UF will only have the forwarding, so it will send the data to HF, then HF will receive and it will send to the indexer. Then at indexer, and what port should be enabled? The port number 997 should be enabled on the indexer. So port 997 should be enabled on indexer. So we have three indexers. So let's suppose we called it IDX1, IDX1, and this is IDX2 and IDX3. So we have three indexers. So indexer will receive the data on 997 port. So we'll have to enable this. We'll have to enable receiving on the indexer, and how the, like it receive the data on from the HF, and how it will replicate, how the replication copy happened between indexer. It will happen on port number 8080. So what is the replication port for indexer? 8080. So 8080 is the replication port for the indexer. So I'll make it so it will be visible if you guys wanted to see later, maybe. Okay, let me write here. Okay, now it's visible. So 808 port is for replication between indexer. So like it's have one copy of data, how it will replicate to the other indexer? It will be on 80880 port. Then this indexer, how the replication and search factor will be, who manage this managed by the cluster master. So this is connected to the indexer cluster. So this is our cluster master. So I just called it to CM, and this connection is happened to the indexer on which port? 8089. Similar to that, this is our three search ad. I just took three search ad, sh1, and like this is the on-prem cluster, on-prem setup. This is not the cloud, for your information. So we are going discussing the on-prem. Yeah. Three. So we have three search ad. These three search ad in cluster, and they are connecting with the cluster master. So I will explain you how it will work. So this connection is also happen on port number 8089. So when our user is logged in, so where user is logged in out, like this is the three ad cluster, and this is on most of the company we have the load balancer. So this load balancer is nothing but it's a group of cluster which is which is given a name, which common name. So it will balance between these three search ad clusters. So we'll get a common name, like I would say, let's suppose we have the let's suppose we have the company called ABC, and he wanted to have his own domain name like Splunk. Like it could be similar to that. They wanted to give a different URL for abc.splunk.com. So now we can access AB, this our search and cluster through abc.splunk.com. So we don't log in, we don't need to log in on individual search ad. Instead of, we'll just access the load balancer URL. So this is nothing our load balancer. We call it load balancer. Okay, so user can log into the ABC URL of the Splunk, and the request will go to the cluster master, and then cluster master will let us know which indexer is available. So it this request will be go like this, and it will return the data back to the s- user at the search head interface. So how that communication happens, search head will request, it will go to the Splunk cluster master, and cluster master will let us know the search head that which indexer is there. He will request that information to that indexer, and then indexer will return the data to the search head, and then visible on load balancer URL to the user. So user don't know what is this, what is the indexer, what is cluster master HF. So user will only know about the universal for which is installed at their system, and which is the which is the load balancer URL of Splunk. So this entire structure is nothing but a Splunk architecture. So there are two more components which is we don't require the dedicated server. One is the license master. So we could have the license master in one of the HF or one of the or cluster master. So it don't require the dedicated server because it don't take much space. So instead of that, I will just put it here itself. So license master is nothing but to maintain our license. I'll just put LM. So license master is nothing but to maintain our license. So whatever key we got, license registration number we got from the Splunk, will have to upload in one of the server, and other will join them as a slave. So this will become a license master. HF indexer said will be a like a slave for the license master, and they can communicate the license usage to the license master back. Okay, and license calculation is happen. I will make a separate video on that. License calculation happen from overnight to midnight. So this is the overall architecture of the Splunk. If you guys have any doubt, you can let me know in comment. I can explain, or I will try to create a separate video for that topic. And for you guys, I will just go through one more time the overview. The data start flowing from here. These are the four client server where UF are installed. That data transfer, it will through the on the port number 9997, then it will pass through the HF, then it will send on 9997 port to the indexer. So on HF, receiving and forwarding port should both should be enabled, where in indexer only receiving port. So actual storage is we required on the indexer. So most of our storage will be on indexer only. So we have 1 TB of storage, maybe 2 TB according to the license and the data we are ingesting into the Splunk. Then this indexer cluster make communication to the cluster master, and searcher also make the communication to the cluster master. So whatever request come from the searcher, the cluster master will let us know like why what indexer is available, and you can go and take your retrieve data from there, and you can represent at the UI configuration. So user will log into the load balancer URL. They don't know about indexer HF and uh, cluster master. DS is nothing to distribute the configuration over the set of servers or other component. Mostly we are using for the HF and UF universal forward. So it can distribute and maintain the consistency over the UF. So this is the Splunk architecture, guys, and please let me know if you have any doubt. I will try to explain in my next video, or I'll make a separate video. And thank you for your support, guys. Please share, subscribe, and like our video.